Okay, so we're gonna work on exercise 2.11, and so I'm gonna draw this one out on graph paper, so that's a little clearer, I hope, anyway. And we start with a plot of the velocity in the x direction in meters per second as a function of time, and we have a few points here. We know that this thing looks like, well, that's 1, 2, 3 seconds. This is 1, 2, 3, 4, 5, 6 seconds. And we know that at t is equal to 3 seconds, that's our line, or that's a point there, and we have a straight line that goes through those points, and it looks oops, one, what did I do here? Oops, that one didn't go there. It goes here, and so it looks something like that's our line. Okay, that's our velocity as a function of time. And we're also told a little bit of information. We're told that the initial position here is 2.0 meters at t is equal to 0 seconds. Okay? And we're asked a few things about this. Okay, first of all, we're asked at t is equal to 2 seconds, what is the particle's position? So we're going to start with that. Okay, so we want to know what the position is at 2 seconds, and a common notation is we want to know what x of 2 seconds is. Okay, so we know the velocity, and we also know that the velocity is a straight line. So we can actually calculate what the acceleration is. We know that the slope of this line, so the slope, which actually is equal to the acceleration, is 2 meters per second per second. Okay, so that's how much the velocity is increasing. So we know that the acceleration is constant. And we also know what the initial position is. Okay? We also know that the initial velocity is 0. So it turns out that we have everything that we need for this problem. We recognize that because the acceleration is constant, that we get something that's going to look parabolic. That the position is going to look parabolic. And we also know that since the initial velocity is 0, we know that the form is going to look something like the initial position where I start plus 1/2 at squared. Now, how do we know that this is so we might just call this a guess, actually. Okay, so let's assume that this is first our guess. x0 plus 1/2 at squared. 1/2 is a constant, a is a constant. So we know that when we take the derivative of this guy here, we get the slope. And we know that when we take the derivative, our slope has to look like this. So let me do that. We'll refresh our calculus a little bit. That we know that dx dt is going to be the derivative of x0 plus 1/2 at squared. And the derivative of a sum is a sum of the derivatives, so it's d dt of x0 plus d dt of 1/2 at squared. Well, the derivative of this guy is 0, because it's a constant. And I bring the two constants, 1/2 and a, outside, over 2, and I get the derivative of t squared. And if you look up your rules about this sort of thing, you'll remember that we bring down the power and reduce the power by 1. And so I get 2 comes down, I get a, let me just do it, a over 2, I get a 2 comes down, and d dt of t squared, well, that's t. Okay? So I end up with a times t. And of course, that's the equation of a line. So this is a line with 0 y intercept. And that's exactly what this is a plot of. Okay. So I'm going to go to the next page here. All right. And so carrying on with this thing, we know what the acceleration is, which means we know that the expression is going to be where I start, 2.0 meters, plus 1/2, well, times the acceleration, which is 2 meters per second, times t squared. And so that's actually all that I need. Now, what does this thing look like? Well, it looks a little something like, I'll try to draw it out here. It looks kind of like that. It's a parabola. And if I plug in all of those numbers, then I end up with an expression. Well, I end up with x of 2 seconds. This is going to be 2.0 meters plus 1/2 times 2 meters per second, and t squared is going to be 4 seconds squared. Units cancel, and I have 2 plus 4. That's 6 meters, and we are good. Okay, so that's the first part. All right, and then the next part, we're asked for, or so in B, we're asked for what the velocity is. So we want to know what the velocity is at 2 seconds. All right, and we just look to the plot. So I'm not actually going to do that now, but I just look at the plot from the previous page, and I can see that this is 4 meters per second. So there's really not a lot of work to do there. And then finally, we want to know what the acceleration is at 2 seconds. And we've already done this. We've recognized that the slope is constant, and we've already found it. It's 2 meters per second. And we're done.